Let's begin our study of physics by observing. Take a moment right now to observe what each of your senses are sensing at this very moment, right now, wherever you are. What do you see? What do you hear? Do you smell anything? What objects are you touching? Does your tongue taste anything? Without getting too metaphysical or philosophical, life presents us with experiences and a universe for these experiences to occur within. The study of physics is the study of what exactly is happening physically within our universe, and more importantly to a physicist, why does it happen? In order to describe anything in our universe concretely, we need to marry physical phenomenon to mathematics, the language of the universe that we have invented or discovered depending on who you ask. When you were observing your senses earlier, you were observing some of these physical phenomena to which we will assign physical quantities. There are three basic ones that we'll start with, and then we'll build out from there. They are time, which we measure in seconds. Length, which we measure in meters. This can also be called distance. And mass, which we measure in kilograms. Many other physical quantities, it turns out, are just combinations of these three basic ones. For example, velocity is just measured in meters per second. And acceleration is measured in meters per second squared. Another one is volume. Which we measure in cubic meters. And the last example I'll say is density. Which we measure in kilograms per cubic meters. How much mass is stuffed into how much volume? Density. These units that we are describing, these quantities reference what one of a certain quantity is. And we are defining them to be something. It was arbitrary, and now we stick with these definitions. They are, in essence, reference standards to which we can compare other things. For example, if we have an object, say this car, a Ferrari 488 Pista, it still has it. Well, one Ferrari 488 Pista, if you were to measure it lengthwise, is equal to about 4.6 meters. And so what that means is that one Ferrari has a length of 4.6, just a number in mathematics, times 1 meter stick, a very physical thing in our world. We use the metric system in science to describe our quantities. And the metric system has various prefixes that it would be worth your while to get acquainted with. You can find little helpful breakdowns of it all online. Here's an example picture. But we always need to specify the units of a quantity that has them. Otherwise, we aren't talking about anything, or anything physical anyways. And we aren't doing physics, we are just doing mathematics. A length of just 4.6 doesn't mean anything. Expressing quantities with an appropriately scaled unit with the metric system allows us to understand the magnitude of the quantity a little easier at first glance. For example, if I told you it's a little over 30 million inches from Klein Library to SpaceX headquarters, we have no concept of how far that is. Instead, if I told you it's 475 miles away, you have some concept of how long it might take to drive there, and you might even guess that it's within one state or two from our own. It's in Hawthorne, California, which is in LA County, so you'd be right. To scale units up and down, the prefixes of the metric system, and also to convert units from one unit to another, sometimes called a dimension, right? We perform something called unit conversion. This involves using conversion factors. A conversion factor is something that relates one quantity to another. Like, for example, there are 4.6 meters to one Ferrari 488 Pista, or there are 100 centimeters to 1 meter. So we go from car to length, right? One dimension to another by using a conversion factor. So 1 Ferrari 488 Pista times our conversion factor, being that there are 4.6 meters per 1 Ferrari 488 Pista, means that we are now in 4.6 meters. We're now in the units of length. If we went from meters to centimeters, we can take that 4.6 meters, and use a conversion factor to say that there are 100 centimeters in 1 meter. And therefore, we're at 460 centimeters. We use as many conversion factors as we need to arrive at the units that we desire. So if we wanted to go from miles per hour, so this is going to be top speed of this car. If we wanted to go from miles per hour to meters per second, which is a more common speed unit in physics, is the metric system. The top speed of the vehicle is 212 miles per 1 hour. So we might need to use a couple conversion factors. One, for every 1 mile, there are 1.609 kilometers. And for every 1 kilometer, there are 1,000 meters. And then for the time aspect, in every 1 hour, there are 3,600 seconds. And so we multiply all the way across and divide by the total denominator, and we get 94.75 meters per second. And one last example to finish this video out. The density of gold. We can get the density of gold. So density of gold. We can get that in units of pounds per cubic inch. So pounds per inches cubed. And we can convert that to grams per centimeter cubed. convert it to the metric system. So we start with the density of gold being 0.698 pounds per 1 cubic inch. There are, for every 1 pound, 453.952 grams, and in every inch there are 2.54 centimeters. None of these things do you need to memorize. You can look them up. Physics is not about memorizing. But see, we have cubic spatial dimensions in the denominator. And so what we need to do when we're converting inches to centimeters is we need to do it 3 times for each of the 3 spatial dimensions. And so we cube that conversion factor. And our result is 19.32 grams per cubic centimeter.